Hello, we are here for one more lesson of this TFlexCam training course, and the topic for today will be the wire cut machining. So we have several technological processes available, among them wire cut. Let us see a couple of examples to show you what it is possible to do with this wire cut. The first mode will be straight cut. So very simple. For that I will create a very simple geometry, a path, and going straight now to the CNC menu, among them, okay, the 2D machining. So I have wire cut, and I will choose the first one, a single contour, okay, a straight cut. So simply toolpath name, tool name, I will say 1. I can define a couple of things: rapid feed rates, working feed rates, allowance, number of passes. So choosing the geometry, allowance 0, so it will do the machining on top of my contour. And you see in red on top of my contour, which I can simulate. Okay, one pass. If I say now, for example, allowance, let us exaggerate and say 5, so it will go in one of the sides. I did not define a correction, so just one of the sides. And if I say more than one pass, basically it will pass several times in the same place. Okay. So very easy. We have other parameters that we will see also in the other modes. We can see them already, because these are 3 parameters regarding the wire cut that can be defined with functions, with numeric values that will assess functions on the programming. Let's create one other geometry, a different kind of geometry. For example, with some straight lines, so a couple of graphic lines. For this closed contour, I need to create an edge. I will choose my parameters for invisible edge and create a profile on the outside. Automatic mode. Okay, I have my profile created, and I can go to CNC, again wire cut, again a single contour cut, give it a name again, and simply choose, and okay, it is created. Again, I can simulate, play. Okay, so open cut and a closed cut. Now I can show you other things, like for example the part thickness. Okay, I have defined 10, but if I say 100, okay, the calculation, it's also easy. Now completely different height on the cut. Then we have another interesting thing, which is the correction, that can be on or off. Okay, if I say on, I can say on the left or in the right, and it goes on the direction that I'm working with. I can point the correction with a number, and this number will be related to the table on the machine controller, or with a value that I can say, let us again exaggerate and say 5. And you see that it will go out, and it has some interesting behavior that on the corners will round the corners, okay? But I can say I don't want these rounded corners if I go on the additional parameters and say non-tangential, and you see straight movement. Or I can say in these additional parameters with degeneration that will create some, this particular case not going very well, but let us say tangential now, and let us say radius correction, not on the left but on the right. And you can see that with degeneration it's allowed to have this kind of behavior in the corner. So if I want to take these things out, I take with degeneration, and the contour it is different, okay? These are different options to work with the parameters also. Then we have also some nice feature, which is the counter contour. Instead of going on the normal direction, I can say go on the opposite direction, okay? And it will go on the opposite direction. Let us try to simulate, okay, and start it on the other direction. And we can have also, let us take this correction, radius correction out. Let us open, take this out also, and say rounding radius, which we can define in our geometry. You see, it will make one exterior radius as one value and one interior radius as another value, okay? So this is also a very interesting option to work with, and which does not need to have geometry done. It can be done with parameters. We have also this M01 that is a conditional stop that we can force on the program. So if we say, okay, do it, machine simulation, you see that we have one M01 somewhere in the program, near as much as possible the point that was defined, which was the point 00, okay? And for these options, it's I think it's everything. So this is a straight cut. All of these options are available for the other cuts. So it's a mix of what we can do. Let us do now a different kind of cut. This is the first one, a single cut. But we have also the possibility to make one angular cut, okay? Basically, the parameters are the same. We can give it a height, let us say 50 mil in height, and let us say a slope angle of 3. So all of this is still valid. Let us see if it did not calculate, sorry. Let us start again. Angular cut. Okay. Slope angle 3, let us say 50 mil, and okay, no problem. And let us see if it was calculated, and do a machine simulation. Okay, as you can see, the angle is not very big, but you see that the cut was done, okay, in angular cut. And for sure now we could apply all of these corrections in micro joints and whatever. Okay, so this is the second mode. This is the second mode, the angular cut. Now we have also the possibility to create a double contour cut. Let's create a new geometry to show you this and a couple more options. Let's create simple geometry also, as always. So 50, 50, 50. Couple of radius. Now create some graphical lines. As we've seen, creating an edge, so profile, invisible, and it is okay. Now I will create one inside geometry, and one of the things we must be careful, it is the number of elements from when we are working with two contour cut. The number of elements of both of the contours should be the same. So let us create something similar. Also create some graphical lines. Okay. And also a profile. Okay, done. So two profiles. Going into CNC, again wire cut. Now double contour cut. One other important thing to notice is the first contour is always the base contour. So one contour and the other contour. We can give a thickness, let us say 50, and let us calculate this and do a simulation. Okay, very easy, very straightforward. What can we see here? We have loops and micro joints. The loops we've seen already, the tolerance angles. We've seen this precision and circular interpolation. If we have radius, and if the software detects it is an arc or a circle, then it will do a function. Let us do a simulation. We have this G02, which is arc, so it will calculate a few points. Okay, let us, you see the amount or the size of the program. So if instead of this I take the circular interpolation and continue to give the same parameter, let us calculate it also, and you see the size of the program. It will do the same thing, but it will put a lot of more points in each of the radius. See the time it is taking on each in each corner. Okay. So apart from that, I think it's quite easy to calculate and to program this. We can have also this moving on and off, doing some lead-ins and lead-outs. Let us say this kind of approach. So we can have this lead-in and lead-out in radius or in any of the other types of movements. So it's not very complex also. And we can also change the start point of this. So this is the start point, but when I'm going to calculate the program, if I say node and I want the start point to be in here, so you see rapidly change to another position. So it's very easy to deal with. Then we have also another type of program that it's called the spiral cut, that I personally I'm not a big fan of it. But I must say that it's another mode. Okay, we have it here, so we must consider it. Let us create another geometry, not simply a circle, doing the same procedure. You know it already: parameters, profile, invisible, and now CNC wire cut, so spiral. Not this one, sorry, wire cut. I'm not sure. Let us try it again. Or a spiral cut. Okay, we have it here. You see that basically it will do a continuous movement to cut material. So if I say instead of one, which is quite small, if I say 5, so it will create something like this, which we can also simulate. And it will follow any type of geometry. If instead of a circle it is other geometry, it will create a pattern like this, not very complex. Finally, we have two functions. One, it is the engraving text. So for example, if I go and write down something like CADsoft, I can go into CNC, so engraving. Okay, I can say this text, and basically I have simulation. You see, let us simulate it. It will contour my letters, okay, with the thickness that was defined. So I have a part thickness. I could change this, no big problem. And the parameters, the rest are the same. but I can do this type of cut in terms of engraving, which is interesting also. Finally, I have a function called the goTo. And the goTo basically allows me to move in terms of G00 or G01, which if you know, this is the movement, fast movement or working speed. And we can do this movement, moving one X after the other, or the two at the same time. It depends on the machine, because different machines have different behaviors. But we can define this type of movement and then pointing to one particular point. So this, I have it, okay, but let us do it. And what happened, it is, I'm not sure if it has done something. Yeah, okay, in fact it has done something. It created a movement to a point that for sure, if I go into draw and create a node somewhere, let's try a better example. A node somewhere around here, for example, CNC wire cut, the goTo to this point in particular, calculated machine, and now, okay, now it has done something. It has no graphical look because it's a simple movement, but basically it created this movement, and we can point, for example, to holes to define the entrance of the wire, or for some other particular necessity that we may have in our program. Basically, these are the options we have regarding wire cut machining. Any questions, any help, you know how to reach us. Let us know your examples if you have them. It may be interesting to share with us also. And anything, you know, emails or comments in the YouTube comment video.